Good enough. All right, if you're just joining us, start in a few minutes. You're in the right place. This is the infamous Tom Hatch and Pop into the Future with Plugin-Oriented Programming. If you're just joining us, we will start in a few minutes. I expect that Tom's taking a little break. He has back-to-back presentations, so we will give him a few minutes to stand up and walk around and come back into the session. If you're here, this is Pop into the Future with Plugin-Oriented Programming. Awesome. While we're waiting for Tom, feel free to say something in the chat. Let us know where you're from or why you're interested in this presentation. Oh, here he is. All right, let me give. There we go. Hey, Tom, I can hear you.
Hey.
Hey.
Yeah, my camera's not turning on to everyone's benefit. Let me refresh. I'll be right back.
Yep, no worries. All right, while Tom's refreshing, yep, I think everyone's probably getting familiar with the platform. You can double-click on any windows to make them bigger. There we go.
Okay.
All right, we'll give people a few minutes to come in. Did you get a break between your last session?
Did I get a break?
Yeah.
No, so my last session was phenomenal. This starts at 11:15, right? So I'm okay shooting the bull for a minute?
Yep, you got a minute. Go for it.
All right, thank you, sir. No, the last session was phenomenal. It was with Dirk. I'm not going to try and say his last name. Mein Deutsch ist nicht gut. But it was with Dirk, and we had a lot of fun, and I got to call Dirk old. And he seemed to take that well. And Thomas wants us to continue talking about cars. And I don't think that's going to happen. Sorry to disappoint. We'll see if there's enough time at the end, or if I'm actually good at delivering this presentation and I can fill the time. Unlike failing to deliver the presentation and running out near the end. And also realizing that the light is suddenly not very favorable to me in this room. Thank you, Tom. I appreciate it. I work hard to deliver good talks. There was one I delivered that I feel terrible about years ago back at DockerCon.
What was wrong with it?
Oh, I just bombed it. Like, I don't know what happened. Like, I just kind of broke down, and it didn't go well. And I actually didn't give a talk again for like 3 months, and I had to kind of pull myself back together. It was so embarrassing. It hurt. It hurt me in my bones.
Hopefully it's before YouTube or...
No, I don't think it ever made it up there. So, all right, Dave. So who talks first? Do you talk first? Do I talk first?
No, I'll hand it over to you, Tom. Do you want? Are you monitoring questions yourself, or do you want me to save those for the end?
That's a solid question. I think if I'll monitor them myself. It's very common, of course, that a question will come in and the answer is forthcoming in the presentation, which makes it easy to just kind of keep going. But yeah, I mean, let's just see how things roll.
Awesome. I'll drop and hand it over to you.
All right, let's dance. Now, welcome to SaltConf 20. I've always enjoyed SaltConf, but I must admit, for years and years, at the end of every SaltConf, I found myself desperately sick for about 3 days. And that was primarily because I vastly overworked myself trying to just deliver SaltConf. And so on one hand, I miss seeing all of you. Many of you who are here are my good friends of many years. And I always look forward to being able to see everybody at SaltConf. But on the other hand, I don't think I'm going to get massively sick. A 1-day virtual conference is a lot easier than a 3-day in-person conference where I'm running around like mad. So the talk that we have today is on POP. Now, many of you may be aware that POP is kind of my new baby. I've been working on this for a long time, and it really grows directly out of SALT, but has evolved into a much more general purpose approach to software development. POP stands for Plugin-Oriented Programming. Plugin-oriented programming is a new programming paradigm and software development model that we have been using inside of SaltStack for a number of years. All of our new software is built on top of POP and utilizes the plugin-oriented programming to great benefit and great effect. It really helps us accelerate our software development internally, and we've also begun to see more and more people use POP moving forward. If any of you went to Nicholas Hughes' talk right before this one, he was talking about Item, which is a POP project. And so it has been, frankly, just really exciting to be able to see this new component that I put together that we announced just last year. We only started to really see traction with it about 6 months ago in the wild, but it's starting to get more and more excitement. We are up to POP version 15, and we've added quite a lot of power into this platform and solved quite a lot of the problems that we run into when trying to do something as ambitious as make a new programming paradigm. So let me talk a little bit about what plugin-oriented programming is. Plugin-oriented programming is a new programming paradigm that seeks to solve, or at least address, many of the software development challenges that we've run into in the last few years. Software development has changed dramatically in the last decade. And as such, I've come to the general conclusion that we need to fundamentally change how we're creating and developing a significant portion of the software that we have. And so let me talk a little bit about what POP is and with respect to its origin. This is SaltConf. And so many of you are familiar with SALT. And SALT has a concept inside of it called the SALT loader. Now, when I started working on SALT, I wanted to make sure that everything, I shouldn't say everything, but much of it was pluggable. And as I worked on SALT, I became more and more and more obsessed, really, with plugin-oriented software design. Because I saw that plugin-oriented approach is what made SALT powerful. And over again, I wanted to use SALT's loader in a standalone piece of software. And so since it was part of SALT and really deeply integrated into SALT, I created a project years ago called Pack. And Pack was me just ripping the SALT loader out of SALT. And I started to realize, hey, there's a lot more that I can do with this when it's not tied to the rest of SALT. And so I played around with the concept. I rewrote it in a number of different languages. I rewrote it in OCaml, C, Go, Rust, Nim. I didn't get very far in Nim, although I love Nim, beautiful language. And learned a lot of different things. No, I didn't try VLang, sorry, just those that I listed. And yes, Randy, Nim is fun. I love C transpiler languages in general, like Vala and Genie. I love it. Anyway, so I ended up writing it though in Julia. And I'm a huge fan of Julia. There's a lot of things in there that they're doing that I find just incredibly exciting. But when I rewrote it in Julia, to make it work, I had to make a number of compromises. And in those compromises, a lot of new ideas spawned. And so then I went back and rewrote it in Python and called it Pack2. And this is where I started to realize that I wasn't just writing a slick little plugin system. And this foray into multiple languages was maybe a year and a half of slowly playing around at night. But I'd realized that I'd created a programming paradigm and that I needed to rewrite it yet again in Python from scratch and call it something new. And so that's when I started calling it plugin-oriented programming, because I'd realized this is a new programming paradigm, and that many of the benefits that I was trying to get into this plugin system were all of a sudden becoming available for plugin or for this entire paradigm, and that they were defining an entire programming paradigm. And that I began to realize that it would be able to solve very specific development problems. I changed my focus from learning about how this thing could possibly work and shifted my focus into answering the question of what capabilities and power should be added to this paradigm so that we're able to move forward in a really strong way and create something that can make software engineering easier for everybody involved and solve some of these software engineering problems of today. And so let's talk a little bit about just a few of the high-level issues. Software projects have become massively monolithic. And one of the things that surprised me, particularly in the last 10 years, is how many open source projects have become monolithic. You see, monolithic software and open source don't traditionally go well together. It might feel kind of natural today because we know about things, there's things like MongoDB, there are things like these massive databases. The Linux kernel is monolithic, for instance, at least from a fundamental design perspective. And I've got to back up and go over the fact that the Linux kernel no longer follows a purely monolithic architecture since 2.6 and yada, 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 yada. I'm well aware of that. So, but the issues that we run into is that software projects are more monolithic than ever. About a year ago, which in COVID time means 400 years ago, Microsoft came out with a study where they stated that, to their great surprise, the larger a software project got, it became exponentially more difficult for it to be developed. And I remember looking at this study and thinking, well, yeah, you guys had to do a study for this? It's incredibly obvious. But at the same time, many polls are showing that developers are managing as much as 100 times as much code as they were 20 years ago because of the vast size of these code bases and the vast amount of code that needs to just be managed now. When you bring in a new engineer or a new engineering team to a large code base, the spin up in that code base can be incredibly painful and can take significant amounts of time. And you end up having someone dedicate large portions of their career to understanding a single code base. From a system administrator perspective, I'll make an old sysadmin joke. This was the case for SendMail, for those of you who have used SendMail in the distant past. There was an entire cadre of people whose entire careers were based around just knowing how to configure SendMail because the thing was such a freaking beast. And so that monolithic aspect of software is extremely dangerous. Thank you, Thomas Phipps, for the shout out in chat to M4 and the pain of SendMail. And so as we come back and we look at large code bases that can transfer, there's also what has become the bottleneck of today. And I'm going to argue that the bottleneck of today is a combination of code review and testing. And it's not unique to us. Very recently, Linus Torvalds and other core Linux kernel maintainers have come out and said that, no, we don't have a problem with new maintainers to the Linux kernel. We can't keep up with code reviews. There aren't enough people who are able to come back and review the code, let alone, again, we also keep up with testing. And so testing is becoming a bigger and bigger challenge, which is ironic because we go back 10 years when we began DevOps and CI/CD pipelines and automated tests, and we thought that we had solved it. But something magical happens when you automate something. The reaction to an automated process, from the human reaction to an automated process, is to push as much crap through the automated pipe as can be pushed. And this is an important thing really to remember about automation in general, is that when you create those automation pipes, then you create an easier mechanism for people to push more stuff. And so people overload those pipes, and they tend to abuse those pipes more and more. And now we have a testing problem again, where we have significantly better tests and continual tests, and we're running so many more tests than we were in the past. But we still have a testing problem again, because tests are still taking so much longer because of the size and scale of the tests that we're running. And so software development is different. And let me go into a little more color here as well around why software development is different. Because when we come back and we look at software development today, what we're looking at is software development that revolves around a totally different paradigm. In the 90s, it was all about desktop applications, desktop UI applications, and object-oriented programming was incredibly well suited to the task. In the 70s and 80s, it was all about databases and operating systems. Procedural programming was well suited to the task. But today, we have a combination of cloud infrastructure as well as these SaaS-based applications and UIs existing inside of web browsers. And this has created entirely different challenges when it comes to the authoring and maintainership of software, because we can make software applications that are far more complicated than what we used to be deploying as a desktop app, because it ends up consuming an entire data center, as opposed to simply looking at it and saying, well, I hope that this Office suite is going to successfully run on someone's laptop with 256 megs of RAM. And so what we end up with is that the paradigms around development and delivery also have needed to change. And we've seen a strong push towards a couple of those core ideas inside of software development. Core ideas that go all the way back to the 60s and 70s. Things like monolithic design versus a micro design, for instance. Things like Unix-style interoperability versus complete cohesive components. Tightly coupled versus loosely coupled or decoupled development and models. And so what we end up with is needing to ask these questions about where did we come from? Where are we going? And why is it that this crazy guy, Tom, thinks that it's valid to get in a presentation and peddle a new programming paradigm? So first, let's talk a little bit about where programming paradigms came from and where software development came from. software development fundamentally came from, and for those of you who go back to computer science school, I don't know if they're still explaining it this way, but the first time somebody sat me down in a class and started to explain this is what code is, they said, look, code is just an abstraction to tell the computer how to do things in a way that humans can more or less understand. And that's what a programming language and paradigm is. It is saying, look, we need to take human to assembly as efficiently as we can. And so we've got math operators and procedures and functions, and it grows out of that system abstraction and still has very close ties to the core of computation, the origin of computation, which is mathematics. And so that's really where our language constructs and our larger software engineering constructs still come from. And so the next thing that we look at is that object-oriented programming, which is still dominant today and has many merits. I'm not an OOP hater, even though I don't like using OOP anymore, but it has many merits. Object-oriented programming came from constructs that actually made the creation of programming languages easier. When object-oriented programming was created, it wasn't created with the thinking in mind of saying, oh, we're definitely solving the monolithic software problem. Instead, what was made in large part to create a more microservice-oriented approach to software has been turned into a monolithic software development environment through some of the constructs inside of object-oriented programming. And then another phenomenon over the last few years is that many of these programming paradigms have evolved together and merged, creating all-in-one grab bags of, well, we're just going to let you code how you want to code. And finally, software development problems have changed so dramatically in the last 10 years that I think that it's definitely worth reassessing on a more fundamental level how we write code. And so the answer that I'm trying to propose is that we've got to solve both sides of the coin. You see, microservice style design has its flaws in solving the last mile problem and delivery. It also has its flaws in interoperability. And then last mile problem is a big flippin' deal. You've got to be able to deliver that software, whether it's in a data center or out of a data center. And we're solving the difficulty of a microservice delivery design with the complexity of Kubernetes today. And when we look at things from a software engineering perspective, we need to be able to solve that delivery component. And this is so much of the reason why monolithic design is so popular, because what we end up with is that it's really easy for us to build and deliver this thing in this monolithic way. And when you're writing software, you don't wake up in the morning and say, I'm so excited to implement a new build system, right? To facilitate the fact that I want to compartmentalize this in an elegant way. And so POP is built to be able to solve both problems, that it is built natively to be able to deliver and build and develop software with the benefits of monolithic design and the benefits of monolithic delivery, while still allowing everything to be pluggable and mergeable. And that allows us to be able to deliver, hopefully, the best of both worlds. The next thing is that I wanted to avoid complex models and concepts. As ideas evolve, they begin to take on and morph into incredibly complicated constructs. Good software design is simple, direct, and traceable. Good software design means it's easy to find the code that's actually doing the work and that there's minimal boilerplate. Good software design means that it's easy to bootstrap a new developer onto a project, and that as a developer goes from project to project, it's easy for them to know how those projects are going to be constructed. If we have simple models that we base things on, then we're able to move forward more efficiently. And this is why POP is a structured programming paradigm. And for those of you who know what structured programming paradigms are, take it easy. Everything's still going to be okay. Now, compartmentalize. So it's important to compartmentalize the software. And I mentioned this a few times, but it's even more important to compartmentalize software given the restraints that we have today when it comes to software development and distributed teams, sizes of teams, and open source. I wanted to be able to take a lot of the benefits that we see in open source's distributed development model and be able to better utilize those across a broader use case of development so that I can accelerate open source, but also make it so that open source is even more easily integrated into proprietary software. That way we can get the best of both worlds. We can get the benefits of open source development cycles with the benefits that we actually see with large team dedicated development processes. And so this compartmentalization becomes extremely important in POP and in how POP is built. All right. I've got a picture of one of my favorite people, Ken Thompson. And I'm going to be bold and talk about the Unix philosophy, which somebody should type into chat right now. The Unix philosophy is dead. Not Plan 9. So okay. So for those of you watching a recording, somebody just wrote Plan 9 into chat, and that was Dave Evans, and that guy's just a pill. A great friend, good guy. Now, the Unix philosophy is something that I think gave us so much of what we have in modern computing. And there's no way that we would have open source if it wasn't for the foundations around the Unix philosophy. And the foundations around the Unix philosophy really revolve around the shell. You see, they had this great concept called a shell, and they were able to overly simplify all of the interactions between software so that it was easy to say that all software will consume and produce text. All of computing was able to be reduced to streams of text. And so the benefit of being able to just have streams of text as the foundation for computing was that all interoperability was incredibly simple because you would just shove it through a flippant pipe. It was great. And then an overly simplified interface, because all of a sudden we can express the Unix philosophy. We can say programs should be small and do one thing well. Programs need to work together seamlessly. Programs need to be able to communicate in a standard way. But POP seeks to revive the Unix philosophy. And it seeks to do this by saying that programs do one thing and do it well. But instead of having a shell as the interoperability foundation, the main difference that we run into is that inside of POP, the interoperability is a concept that we call app merging. And so something similar in fundamental philosophical context to a shell exists inside of POP, and it's called the hub. And so on this hub, all of the programs that are created can interoperate in a completely seamless way without needing to have any bizarre overhead or any strange interoperability occur, because we've significantly lowered that overall barrier of communication. And therefore, inside of POP, I feel confident to say we have revived the Unix philosophy. Now, next I want to read a quote from an early POP user and someone who's become a very good friend of mine, the freaking creator of Gen 2. I like to use people who are credible. And this is a good friend of mine. His name is Daniel Robbins. For all I know, he's in here. I don't know what session he's listening to. He already knows pop. He doesn't need to be in this one. Daniel Robbins said, pop is becoming a virus because it's taking over my code and killing off weak patterns. I have a lot of code that sort of reached its potential with just modules and classes and was just sitting there waiting for something like this. Daniel Robbins is currently the chief maintainer of Ubuntu, and he's porting significant components of the Gen 2 toolchain over to pop and has begun to see significant benefits inside of how these systems are being used. Bradley just asked, so pop is the new system D, question mark. I'm going to, I like making bold statements when I'm talking about pop. And so what I'm going to say is that if system D was written in pop, it would be incredibly better because it allows you to, again, create all of the componentry that you would still want in a system D and still make everything delivered in a monolithic way, which I think is arguably good for a startup system. But all right, another comment just completely threw me off. I'm just going to have to close this comment thing down. Normally, when I give a presentation, I don't get people who are just constantly bombarding me with questions and making fun of me and things of that nature. So no, I make bold statements all the time because that's what I do. Otherwise, you can't play ball. Okay, to respond to a comment in Slack where I was challenged, saying, "No, you make bold statements all the time, not just about pop." Thank you, Randy. I am a bold man with bold statements. Okay. So let me detract from the comments because everyone who is watching a video of this is now growing deeply angry at the fact that I've been distracted by them. Let me go over a few of the major concepts of plugin-oriented programming. First is that everything in pop is pluggable. The plugins are pluggable, the modules are pluggable, the subsystems are pluggable, entire applications are pluggable with each other. An entire application, if that interface is created differently, can completely replace can completely replace an entire component. The next is the concept of workable code. The smaller a code base is, the more malleable it is, the more transferable it is, the more workable it is, the more replaceable it is. If we write replaceable code, it's easier to maintain. It's easier to move forward. It's easier to evolve. And so this is where the heavy compartmentalization concepts of pop come in. Smaller components of code are incredibly helpful. The next thing is layers. So that we've got layers and that those layers are malleable components. And yeah, that was me trying to be an ogre. And shout out to Shrek. But so if the software is layered, okay, then that means that we can interject pluggable components at different layers of a set hierarchical structure. And this is an incredibly critical component of plugin-oriented programming. And that ties into how those layers are expressed. The layers are expressed in a hierarchical namespace. A hierarchical namespace very simply and directly exposes how this software becomes accessible. And so what we end up with is the ability to step back and say that we have a finite location for all of the components inside of our software. The next concept is that apps are mergeable. Entire applications can be merged one with another in a Lego-like fashion. There's reasons why Lego makes more money than any other toy company, and they've basically got one product, which is blocks that stick together. And it's because there's so much brilliance in the creation of blocks that stick together. Inside of plugin-oriented programming, entire applications natively bind with each other. Again, going back to computer science school, I remember being told repeatedly, you should write your code in libraries. And when you write your code in libraries and then you call the libraries from your application, then your code will be better. And then, of course, we enter into industry and we find out that people just write big O applications. And yeah, sure, they write libraries sometimes. But for the most part, they write big O applications. And those big applications are not generally very well libified. And their components aren't reusable. And their components end up having this direct use case for their specific application anyway. Pop says, I'm not going to fight the wave. Right? People want to write applications, and there's economic and reasonable reasons why they should. I'm not a fan of sitting somebody down and saying, the philosophically optimal way of doing something is over here, so you should do it, and since you don't, you're bad. I'm a much bigger fan of asking the question of, how do people behave, and how can I compensate for their behavior in my design? Because that's what good design is. Good design isn't to sit somebody down and say, follow these rules or you're dumb. Good design is sitting down and saying, why do people behave a certain way? And can I design structures and constructs around people in such a way that creates better outcomes given the nature of their behavior? Finally, we need to keep it simple. And POP is all about keeping things simple. Easy to understand, easy to transfer, but like Salt, still very powerful under the hood. Hey, Dave, how much time do I have in this?
12:10 is when we're ending.
Nice.
20 minutes.
Thank you.
So, yeah.
So the next question is about KISS. I've had the experience that POP's indirection and dynamic function dispatch makes it harder to follow the code when I hacked on Tiamat. Are there plans to create or improve tooling around the indirection? One example, go-to function or go-to definition of a function. Yes. So one of the interesting things about plugin-oriented programming, one is that it's built on top of Python. And so there are certain restrictions as to how we can make it easy to track exactly where those paths are going. And also the pluggable nature means that a path can get redirected based on the plugins that are being expressed, which makes it very powerful to be able to make entire interfaces that are pluggable. But it can also make it difficult, again, to sometimes track code paths. And tracking code paths is a really important component to design. What we really want to be able to do is make it so that from a debugging perspective, it is much easier to track code paths and that it's easier for us to expose that dynamism inside of POP. So again, that it's just easier to track things down. So yes, that is definitely one of the roadmap components. All right. So code is pluggable, mergeable, hierarchical, but very importantly, distributed. Because what we run into from a distributed code perspective is that it becomes really easy for distributed teams to work on code because the code can be broken up into lots of little projects. And those lots of little projects can be app merged together. And when we have that functionality around app merging, it becomes a lot easier for us to be able to say that certain people have complete autonomy over certain projects and that those projects remain small and distributed. When that happens, the test burden goes down. The transferability of code in units becomes significantly easier so that it becomes significantly easier to hand off code from one person to another so that it's easy to say, look, here's a code base that does a specific thing and it's less than 5,000 lines. I can sit you down and go over how it works. And you can come up to speed on how that code works quickly and efficiently. So I have 20 minutes, and one of my absolute favorite things Are you ready for it? A shell. So let's play ball. I'm about to demonstrate how POP works by creating a simple POP project, introduce you to POP seed, which is used to create that initial project, and then also introduce you to the hub and to subsystems. Now, I haven't prepared this demo one bit, which I have to admit is me trying to brag, and hopefully it goes well. All right. So the first thing that I did, and actually let me increase the size here. The first thing that I did was run pop seed. Pop seed is a nice little application that makes the creation of POP projects easier. There's a little bit of boilerplate. And again, it's built on Python. I didn't write a completely new programming language. That would be insanity. And really what we end up with is that POP would be a much cleaner implementation as its own programming language. Yeah, there's one thing at a time. Okay. So I run pop seed, and it creates a number of things for me. It creates a nice little README, a requirements.txt, a setup.py that you go in and put your name in there, and you should basically probably never have to edit that setup.py again. And it creates a Python package, okay? But it also creates this lovely little run.py. The run.py is just a convenience interface that allows you to begin. That's kind of the entry point for the project, okay? And Brian asks, what kind of challenges with Python's type system did you encounter with the hub concept, if any? Python's type system made the creation of the hub and the constructs I'm about to show you so much easier than in other languages. Oh my gosh, it was beautiful. I love Python. So yeah, I haven't encountered problems. So yeah, I'm sure we will. There's problems everywhere. Welcome to, life and whatnot. But, one thing at a time. Okay. So let's start by taking a look at our run.py here. This is the only code, really, that isn't plug-in code inside of a POP project. So what we're looking at here is the creation of the hub, where we import pop.hub, we make a hub, we add a subsystem to the hub, in this case called Poppy, and then we call a function on the hub. And so what's going on is, as you are very well aware, for those of you who know even a little bit of Python or heck, a little bit of software, you can look at this and figure this out. We're creating an instance of a hub. Then we call, as soon as we create a hub, hubs contain plug-in subsystems, or subs for short. And so we create a sub, or rather when we create the hub, it comes with a sub so that it turtles all the way down. And that sub is called POP, where POP's internal tooling and extendability is just natively added to your hub. And so we say, okay, hub.pop, so we're in the POP subsystem. And then we go to the sub plugin, which is used to manage subsystems. And we say, I want to add a new subsystem. And so we have the code relative location of the function on the hub. All the functions exist on this hub. And so then we say, I'm going to add a new subsystem, and I'm going to use the dynamic name, which is a feature inside of POP that allows for vertical app merging, which I'm totally not going to have enough time to cover in this presentation. If you want to learn more about vertical app merging, go to Tyler's presentation, which I sure as heck hope isn't happening right now. That would be awkward. Or watch a video of it later. But anyway, we added dynamic name. That means that pop is going to dynamically discover the poppy subsystem. Okay. Now it's discovered and added the poppy subsystem to the hub, so I can call functions on that subsystem. And so now I just say hub.poppy.init.cli, which is going to be our entry point. And so where is this magical subsystem? If you recall, there was a Poppy Python package. Inside the Poppy Python package, we've got a couple more files. So let me take a look at these really quick. Scripts.py exists as the front end. Scripts.py is really the installation front end, which is used by setup tools. And so it's kind of a Python compensation piece. We got to use setup tools so we can make wheels. I'd love to sit down over dinner and have a lovely throwdown with somebody about why I'm genuinely not a fan of setup tools, but whatever. We have what we have. I'd rather use what we have than rewrite the entire world, only certain parts of it. And so the same kind of thing inside of the scripts.py. Now, the next thing that we've got is the conf.py. And this is where we define the dynamic name. This is where we state, hey, this Python project is going to expose the dynamic name Poppy, and it's going to be found under Poppy. And so if we then go into the subsystem, we will see that there is a file called init.py. And Derek just reminded me that, I want to cat that, no, I want to vim that. Derek just reminded me that we are migrating from PopC to a standalone project called PopCreate so that we better compartmentalize the internals of Pop, so that Pop is more Pop-like. So yeah, there is a new project called PopCreate that will supersede PopC. It's going to be super. Now, you may have noticed that I opened up the file hub.poppy.init.py. That poppy.init is what showed up on the hub, right, as hub.poppy.init.cli, and here's the function. And so for those of you familiar with Salt, this might actually feel familiar because in Salt we use code paths also to define the nature of the internal and exposed API, which I'm, again, generally going to argue it makes software development a lot easier as long as you can properly restrain external access to the internal APIs, which you can do in here. But as you can see, this is all I needed to do to be able to print Poppy works or to appease the programming gods, since this was requested in the chat, that we make sure that the proper bits are distributed to the programming gods. And now I'm going to bite my tongue and not go over the history of Roman and Greco-Roman pagan belief and how those overlays and how this is an orthonic ritual of, I said I wasn't going to do it. Okay, so, but as you can see, Pop now says hello world. So as we come back in here, you'll notice that there's one other line, okay? There's one other line that says hub.pop.config.load. I've mentioned app merging, and again, Tyler's going to cover this in the next talk because I'm pretty sure he's going to talk about how to port things over and create vertically mergeable apps. So I'm excited that he's got an excellent follow-on to this one. So app merging means that we need to define what an app is so that we can merge applications together and overcome the challenge that is the application versus library problem. And some of these problems, I have to admit, are so arguably fundamental that a lot of people don't seem to even think of them has problems. But I definitely think that, again, for every 100 people hacking at the branches, there's one person hacking at the roots. I want me to hack at some roots. So if we want to overcome the app versus library problem, that means we have to unify configuration loading and application startup processes. And this is where that little conf.py file comes in. All of the configuration options and command line flags for an application and environment variables and all of the startup ingestion stuff can be expressed inside of this conf.py, and it is extensively powerful. And when we merge applications together, you can actually put into a separate conf.py that if we decide to merge app A into app B, that app B will inherit some of the command line flags from app A dynamically, which means that every aspect of this allows us to dynamically merge applications together. And so if I take a look at the conf.py, what we can do in here is realize that, to everyone's great surprise, I've been incredibly preoccupied with an acquisition and integration with VMware. I haven't actually written any pop code for like 6 months, which makes me sad, really tragically sad that I haven't been able to write a lot of code. So really what I'm saying is that if I get my syntax wrong, I'm sorry. So I'm going to add a command line option called foo. When I put it to the config dictionary, what we end up doing, I think I can just leave it registered. Okay. Okay, when we put it in the config dictionary, we're saying that this configuration value is going to show up on the hub. Okay. And when we put it in CLI config, we say this configuration value is accessible via the command line. And we're also going to be so bold as to say that we're going to accept it as an environment variable as well. And now I'm going to get a trace back because this is a live demo. Or not. Okay. And so now you can see that we have a new option, foo. And so when we come back and we look at Poppy, whoop, I need to go one more into the subsystem. All right. Now we can say did we ever fix it so that that works right? We did. Okay. They have smiled. Okay. So all of that config loading is completely taken care of for you, and it's loaded into a structure on the hub. The main benefit that we run into here is that config loading becomes completely interoperable and completely seamless across multiple applications. So you may have noticed that it says hub.op.poppy. That's because we're gathering these config options from the Poppy project, which means that if I have another project that takes its own config that's going to be inherited by a separate project, that project's config can still be referenced relative to its own namespace pathing, okay? Which means that you have really clear structural dependency chain optionality. And also that your own application can follow its own loading convention while still exposing its own options to third-party applications. Which also means that you can write config options for application A, and application B can dynamically absorb application A's config options. Okay. Also, where I really, really screwed up, and by screwed up, I just mean lightly neglected, is that I should have done this. Pop actually used to yell at you when you forgot to do this. Maybe I should put that back. Okay, so documentation can go in there too. Okay. All right. I am out of time, but you've been given an introduction to Pop, and I'm going to talk really quickly about a couple of the projects that we're working on. Pop config is the project behind the config system. Heist allows us to create ephemeral agents. It's very cool. Item is basically the Salt config engine, just the state system, none of the transport or anything, exposed completely in Pop, completely pluggable, much more malleable, easier to develop and extend, and as an item-potent language. And Item is really picking up a lot of steam. And then I'm very pleased to say that Randy Thompson's here, my good friend Randy. Guy's fantastic. He's been huge on Tiamat. Tiamat allows you to build Python applications into single binaries so that they're kind of like Go binaries, just a little bigger because it's freaking Python. But it bundles Python in those binaries with everything. Randy's been fantastic as really one of our top community guys on Tiamat. I'm hugely excited about Tiamat because, like I've said many times in this conference already, it's all about solving that last mile problem. It's all about making it easy and consumable to be able to deliver that software at the end of the day. Tiamat does that. Tiamat allows us to take projects as complex and powerful and frankly ridiculously large as Salt. Salt being one of the largest Python projects in the world, and making it so that it's easily and reliably distributed as a single binary. And Tiamat is already becoming more and more widely used for a vast array of Python projects. And it solves almost every problem that which still exists with projects like PyOxidizer and PyInstaller, which has been a really, really fantastic thing to watch. There's one question I'll try and answer really quick because I have like 40 more seconds. Is Item a pseudo V2 of the pillar systems? Or should I say what people are using pillar for versus what it was intended for in private storage of key value pair versus entire application configure tables or key value pairs? Item is not a replacement for pillar. It isn't a change in pillar. Item has features inside of it which are pillar-esque, which allow for arbitrary value insertion into the system. But Item is not pillar, and the pillar-esque systems in Item are made to be much more pluggable than even pillar is, so that we can receive injection of data, again, from more arbitrary sources. Item is really a newer version of the state system. All right. I'm done. I concede.
Awesome.
And I didn't have like a VMware slide yet.
Yeah, just imagine it's there. Yeah. So, like Tom mentioned, if you want to continue the discussion with Pop, Tyler's session begins in 5 minutes. I'll try to post a link as soon as that looks like any moment now. It should be available to you, and hopefully all 70 of you just kind of move over there, and we'll dive even more into Pop. Tom, thanks so much for your time, and thanks for everyone for attending.
Yeah. Thanks for everybody putting up with me talking again. I don't talk for another like hour and a half. I might try and get some food. A rare occurrence for Self-Conf and me.
Make that sacrifice to the demo gods after the fact.
Right. They owe me food. I know how orthonic rituals work.
There you
All right.
go.
See ya.
See ya.